Hello everyone. In this session, we are going to talk about this question. A plane flying horizontally at 200 meter per second at a height of 2000 meter drops a bomb. Find the time it takes to reach the ground, the distance of the target, and the velocity of the bomb when it hits the target. So let's visualize this situation. Okay. So I have an aeroplane like this. This is an aeroplane. Okay. So this is an aeroplane and the aeroplane is moving in the right direction with a certain speed, which is 200 meter per second. And at this point, it releases a bomb. Let me show it in a um, the yellow color. Okay. So it releases the bomb at this point, and when it releases the bomb has only the X component, that is the horizontal component, and then it will drop off like this. Okay, all the way up till the ground. So let me draw this height. Okay, and this is our ground. This is the ground, and this height is 2000 meter, which is given to us, and the bomb is dropped at this particular point and it follows a path like this. So let me take this as a origin where the bomb is dropped, and the vertical axis is the y-axis, positive y-axis, and sorry, the downward is the positive y-axis and the upwards is minus y-axis, and the right direction is positive x-axis. So this is my origin here. Okay, and this is our reference frame. Now the first thing that we have to do is to find out the time it takes to reach the ground. Now you can see that in this case the bomb has initial velocity only in x direction, not in y direction. So initial velocity in y direction is 0 meter per second, and the displacement in the downward direction is positive because it is a positive y axis, and the displacement has to be 2000 meter. Okay, because it is the height from the ground, and we have to find out the time. Okay, we know g value, we will take it as plus 10 meter per second square. I'm taking it plus because downward direction is plus. So we have sy is equal to uyt plus half gt square. So this is the equation of motion. Okay, now uy is 0. So I already told you that first of all that when a projectile is falling down, it has two components like this. One is x component, another is y component. Now the motion along the y direction will not affect the motion along x direction, and the motion along x direction does not affect the motion along y direction. They are both independent of each other. So now here in y direction only, if I consider, then the x directional velocity will not be important for us. So sy is equal to uyt. So this is uy is 0, initially no vertical velocity here. So half gt square. So this is half into 10 into t square. What is t square? We don't know. We have to find out. But what is sy? Sy is 2000 meter. 2000 is equal to half into 10. As of now, I am not taking any units over here. I am just doing the calculations. So this is what you will get. 2 into 2000 is 4000 divided by 10. So let me cancel this 0. I will get 400 is equal to t square. So now the t value becomes 20 seconds. So time t is 20 seconds. Okay, so the time it reaches for the bomb to reach the ground is 20 seconds. So we have done this first problem. Okay, now let's find out the distance of the target. That means the distance like this, the horizontal distance when the bomb was dropped, that from that point to the point where it hits the target. So this distance, let's call it as x. Now as we already seen that the motion along x direction is not hampered by the motion along y direction. So our x will be ux into t. Why? Because here, why it is simply velocity into time? It is because in the x direction there is no acceleration. It is a uniform motion. In y direction there is acceleration due to gravity. So x is equal to ux into t. So what is ux? We know ux to be 200 meter per second since it is given to us into 20 seconds. So this will become 4,000 meter. So this will become 4 kilometer. So the x is 4 kilometer. So the distance is 4 kilometer. So we have done this second problem as well. The third one is the velocity of the bomb when it hits the target. Now the velocity when it hits the target will have two components. First is y component Vy and another is x component Vx. Okay, so we have these two components and our velocity will be the resultant of these two components like this. Okay, now what is Vy component? To find out what is Vy component, we have to apply a formula which is Vy is equal to Uy plus Gt. Okay, this formula if we apply, we will get Vy. But Vy is the velocity when the bomb reaches the ground. When the bomb reaches the ground, the time is 20 seconds. So you have to put 20 seconds here. But Uy is 0. When the bomb is dropped, it has the initial velocity in y direction to be 0. So here it will become 10 into t, which is 20. So this will become 200 meter per second. So Vy is 200 meter per second. So this velocity Vy is 200 meter per second. So I will write it here like this. And Vx is also 200 meter per second because in x direction there is no acceleration. And since there is no acceleration in x direction, the velocity will not be hampered by it. So it will be the same. So 200 meter per second and 200 meter per second velocities are there. The components are there. So the resultant will be given by the Pythagoras theorem, you can say. So V resultant is equal to square root of Vx square plus Vy square. Okay, you can say Pythagoras theorem, or you can say that it is the vector resultant, because Vx and Vy is 90 degree. The term 2 Vx Vy cos theta will become 0. So this is a vector addition. So square root of Vx square plus Vy square. This will be 200 square plus 200 square. So this will become 200 root 2 meter per second. So this is our resultant velocity. The velocity with which the bomb will hit the ground is 200 root 2 meter per second. Now what about direction? So if I call this angle beta, then the direction will be given by tan beta. But what is tan beta? Tan beta will be, this is Vy because opposite side. Tan beta will be opposite side, which is Vy, divided by adjacent side, which is Vx. So tan beta will be Vy upon Vx. But the thing is Vy and Vx both are same, that is 200 meter per second. So the ratio becomes 1. And then beta must be 45 degree because tan 45 is 1. So this is the angle.